Okay, here we are in West Virginia. Anyways, how about joke of the day? Because it is the best part of the day. So which of King Arthur's knights made the round table? Well, circumference, of course. Okay, let's spin ourselves around and take a look at another of our measures of dispersion. This is going to be the coefficient of variation. So, coefficient of variation, again, it is a measure of dispersion. And what it does is it allows us to compare those standard deviations of different data sets. Because oftentimes the data set that we've got, the standard deviation is a little bit skewed, and it's difficult to compare the data sets because our mean is different, our standard deviation is different, and it makes it difficult to compare them. So what that coefficient of variation does is it makes the numbers comparable so that we can examine that variation of the means and the standard deviations, and we can see which data set is more reliable and less variable than the other data set. Less variability means more reliability. Let me write that down. Less variability equals more reliability. We like things to be nice and tight, so we want less variability. That gives us more reliability. So what the coefficient of variation does is it compares the standard deviation to the mean, and it is expressed as a percentage. So because of that, we want a lower percentage, because a lower percentage means less variability. Less variability, we want a lower percentage. So the formula for coefficient of variation says, and here is our symbol for coefficient of variation. Coefficient of variation. And to compute that, like I said, you're going to compare that standard deviation to the mean. So you're going to take your standard deviation, you're going to divide it by your mean, your x bar. Notice this is sample standard deviation, sample mean, but it's expressed as a percentage. So when you do this, you're going to get a decimal value, and in order to turn that decimal value into a percentage, you simply multiply by 100, and that will give you that percent. So here is your formula for the coefficient of variation. Pretty simple formula. So we're going to take a look at a couple of examples to see what I'm talking about and how this works. In our first example, it says, as the manager of the human resources department at my firm, we are going to investigate the number of sick days that employees took during the last calendar year. Now we've got two areas that we're going to be comparing within our firm. We're going to look at our marketing area, and we're going to look at our research and design area. So the employees in the marketing area, on average, they took 4.2 sick days. The average number of sick days is 4.2. The standard deviation was 2. So that spread on average was 2, the spread from the mean of 4.2. But in that research and design group, the mean is 4.6 and the standard deviation is 3. So it appears that those in the marketing area did better with that lower average number of sick days, but the deviation could skew that a little bit. So let's compare those coefficients of variation so that we can make it a normalized number that we can actually compare. So for that marketing group, I'm going to get their coefficient of variation. And once again, I'm going to take my sample standard deviation and divide it by that mean, and then I'm going to multiply by 100. So my sample standard deviation for the marketing area is 4.2. Whoops, nope, sorry, is 2. And I'm going to divide it by my mean of 4.2. And then I'm going to multiply by 100. Well, 2 divided by 4.2 is 0, and let me show you that on a calculator here. 2 divided by 4.2 is 0.47619, and we'll drop it, we'll round it to the nearest tens, hundreds, thousands, 10,000s, 100,000s. So that's going to be 0.47619, and I'm going to multiply that by 100. Well, you know that whenever you multiply by 100, basically that just takes that decimal point, slides it 2 to the right. So I'm going to get a 47.619. Now remember, I rounded, so at this point it's an approximation. Should not have equal to symbols, an approximation symbol, but that's about 47.619% for the marketing group. Now let's take a look at that research and design group and get their coefficient of variation. So once again, we're going to take that sample standard deviation and divide it by the mean, and then we're going to multiply by 100 so that we can standardize these numbers and compare the two groups. So my sample standard deviation is 3. I'm going to divide that by the standard deviation of 5.6. I'm sorry, the mean. Oh, golly. Sample standard deviation is 3. Sample mean is 5.6. And when I take a 3 and divide it by my 5.6, I get 0.535714. And again, I'll round it here to the nearest tens, hundreds, thousands, 10,000, hundreds. Oh my goodness, we'll round it there. So I'm going to approximate at this point to 0.535714. I'm going to multiply that by 100. So I'm going to get approximately a 53, because I'm going to slide it 2 to the right, 53.5714%. So now as I compare these two, and I want less variability because less variability gives me more reliability, this is the group that has less variability. So the marketing group has less relative variability. I'm really struggling here. Less relative variability. The marketing group is going to be more reliable in its data. Okay, so let's check another example here, just to make sure we're really good at this. So now we're comparing stocks. And we want to compare stocks because those with higher relative variability are considered to be volatile. In other words, they're less reliable, they're less consistent. So we want a lower relative variability. Lower relative variability is going to be something that's more reliable. So we're going to compare stocks in a given month, and we're going to take a look at Netflix, and we're going to take a look at Hulu. So when we take a look at Netflix, and we want that coefficient of variability, we're going to take our sample standard deviation and divide it by the sample mean and multiply by 100. Now in Netflix, it says that for that given month, the mean daily closing price was 37.4. The standard deviation was 4.1. So I'm going to take that 4.1 and divide it by 37.4 and multiply that by 100. Now, 4.1 divided by 37.4 gives me this number. And so I'm going to take that number, 0.109626. I'm going to multiply it by 100. And what happens here is I just slide that decimal point 2 to the right. And so that'll give me about 10.9626%. That's the coefficient of variation. Now let's take a look at Hulu. Hulu, with its coefficient of variation, I'm going to take its sample standard deviation, divide it by its sample mean, and multiply by 100. That sample standard deviation is 3.2. I'm going to take that 3.2 and I'm going to divide it by that mean closing price of 18.6. And then I'm going to multiply by 100. Well, 3.2 divided by 18.6 is that number right there. And so now what I'm going to do is I'm going to take that number, 0.172043, and I'm going to multiply that by 100, which again means slide the decimal point 2 to the right. I need my approximately equal to symbols because I have rounded. giving me 7.2043%. Remember, I want a lower relative variability so that it will be more reliable, but this is asking which stock was more volatile. More volatile is a higher relative variability. The higher relative variability comes here with Hulu. So Hulu was more volatile. Things are going crazy here in Santa's workshop. Hulu was more volatile. So I hope that you understand that the coefficient of variation, again, it allows us to standardize things. It allows us to be able to compare our numbers because we are standardizing that comparison of the standard deviation to the mean and expressing it as a percentage. And remember, less variability, which is a lower percentage, gives us more reliability. I hope that helps. Have a great day.